Hello students, welcome back to NEET Masterclass with Sparkl. So today I have come up with the topics electromagnetic induction and alternating current. These topics are a bit uh, smaller and a bit easier as well. Though many students face some issues in solving the problems in both the chapters, but trust me on this, in this chapter, the questions are asked from purely NCERT, especially alternating current, or even in electromagnetic induction, there are a mix of theoretical as well as numericals, and they are purely from NCERT. You just have to remember the correct terminologies, do the correct calculations, and read the questions carefully to score marks in this chapter. So today also I have come up with a few questions which are in line with the NEET PYQs and NTA thought process, and you can again expect similar questions in your actual exam on your 21st June. So let's start with the questions. Do them carefully, practice them enough, okay, and do well. So let's start. A series RLC circuit, potential difference across RLC are 30, 60 and 100 volt respectively as shown in the figure. The EMF of the sources. So again, it's a easy question. It's a purely formula based questions. You have to keep the formula on your tips. Now these values are always, when they are given like this, they are RMS values. So the EMF of the source, when nothing is given, we have to find the RMS. Otherwise it would have given ki peak value nikalo ya fir average value nikalo, whatever. When nothing is given, we have to find the RMS value. So we know that V net is equal to under root of VL minus VC whole square plus VR square. All right. So we just have to put the values in this particular formula. So VL minus VC will be 100 minus 60 whole square plus 30 square. So it becomes under root of 40 square plus 30 square, and that comes out to be 50 volt. So this will be my answer. All right. So a simple RLC circuit based question, you have to remember the formulas for RLC. If you don't know it, just do one thing, draw a circuit, try to draw the phasor, and through that phasor, try to write the formulas and you will remember them. All right. Next question. The copper rod of length L is rotated about one end perpendicular to the uniform magnetic field with constant angular velocity. So you might have seen such questions. Definitely, this is a standard question, and maybe it is being treated like a standard result. So there is a rod. It is rotating with angular velocity omega, length L, and the magnetic field here is B. So the EMF induced in the rod comes out to be B omega L square upon 2. So it's a direct result. Have to learn it. You might have done the derivation of this particular thing for your board exams as well. So it's easy, but yeah, it is very likely to be asked in the exam. Okay, next question. If L and R denote the inductance and resistance, the dimension of L by R, it is the inductive time constant, and it has the dimensions of time only. So it is M0, L0, T1. It's very important, very, very important. Similarly, RC is also the time constant, and its dimensional formula is also M0, L0, T1. So you need to remember this. M0, L0, T1, RC and L by R. All right. And under root LC also will have the same dimensional formula. Okay. It is 1 by under root LC is the frequency. So under root LC will have the same dimensional formula of time. So these three things will have the dimensional formula of time. All right. Next question. LR circuit based questions. The capacitor is also there. So it's a mixed concept question, easy question. Similar question has been asked in the exam in previous years. So the switch shown in the circuit is closed at t equal to 0. The current drawn from the battery at t equal to 0 and t equal to infinity. Whenever there is a question on LR circuit or maybe the RC circuit, generally these two times are compared, all right, t equal to 0 and t equal to infinity. So we need to know what happens at t equal to 0. So t equal to 0, no current flows through branch of inductor, no current flows through inductor. And about the capacitor, what will happen, that capacitor can be treated like a wire. Capacitor behaves like a wire. At t equal to infinity, what will happen? The opposite of these two, that inductor will behave like a wire, and the capacitor, through the capacitor, there will be no current. No current flows through capacitor. So this is what we need to do over here. So let's draw the circuit at t equal to 0. How will it look like? So I'm drawing the circuit E. There will be a resistance R. The switch over here is closed. Now there is no current through the branch of the inductor. So there is no point drawing it. And capacitor, we have to draw a simple wire. Capacitor will be treated like a wire. So the entire circuit at t equal to 0 will look like this. This branch I'm not drawing because there is no current flowing through this at t equal to 0, and this capacitor is treated like a wire. So current over here is E upon 2R. They are very simple questions. You just have to learn them once. Okay. Now t equal to infinity. For t equal to infinity, if we draw the circuit, there will be no current through the branch of the capacitor. But yeah, an inductor will be treated like a wire. So again, the circuit will look similar only. But in this time, this middle branch will appear. So again, the equivalent resistance will be 2R. So current at infinity will also be E upon 2R. So the ratio will be 1:1. All right. So this will be my answer. So this is what you have to do in these questions. All right. All right. Next question. Again, a very important question. These type of questions are asked generally, and you just have to apply KVL over here. So AB is part of electrical circuit. The potential difference VA minus VB at the instant when current is 2 ampere. So this current over here is 2 ampere, and it is increasing at a rate of 1 ampere per second. So di by dt is 1 ampere per second. All right. So let's write the equation. So VA minus L di by dt, 1 into this will act like an opposite battery like this because the current is increasing. Di by dt is also 1. So minus 5 minus 2 into 1 will be equal to VB. So this will become VA minus 2 minus 5 minus 2 is equal to VB. And from here, VA minus VB will come out to be 9 volts. So again, a very easy question, a standard question. You just have to practice it. All right. Next question. Radius of a loop is shrinking at a rate of 1 millimeter per second. So dr by dt is given to us as 1 millimeter per second, 1 into 10 ki power minus 3 meter per second. Now it will be minus because it is shrinking. Though we have to just find the magnitude, so we can ignore the sign. But yeah, it is shrinking, so I'm taking it as minus. When loop is placed in a transverse magnetic field 2 Tesla, find the induced EMF when radius is 2 centimeter. So how do you have to do this question? So here the area will be changing, right? So flux will be equal to BA. Now EMF induced, if we write the magnitude, it will be d phi upon dt. Now the B is constant and area is changing. So we have to do dA by dt. All right. So this will be the approach. Like to change the flux, we can either change the magnetic field, either change the area, or either change the angle. All right. So here we are changing the area. Now, what will be the area for the circular loop? It will be pi r square. So let's find the expression of dA by dt. So from dA by dt, we have to differentiate. For dA by dt, we have to differentiate both sides. So it will become pi into 2r into dr upon dt. All right. So this is what is dA by dt. Now we have to just put the values. So EMF induced will become B into dA by dt, area will be pi into 2r into dr upon dt. All right. Now put the values. So it will become magnetic field is 2 Tesla into pi into 2. Radius is 2 centimeter. We have to find the induced EMF when r is 2 centimeter. So it will be 2 into 2 upon 100 into dr by dt is 1 into 10 to the power minus 3. So this thing will become 8 into 10 to the power minus 5 volt, 8 pi. So this will be my answer. All right. So again, it's like a standard question, a direct question, but you have to remember this approach. All right. Next question. A wire of length 4 meter placed normal to the magnetic field, placed normal to the plane of the magnetic field 2 I cap plus j 2 4 j cap is moving with velocity 4 I cap plus 6 j cap plus 8 k cap. The induced EMF. So see, induced EMF is BV into L. Okay, and when we do it, so it will be like L V into L cross B. So we have to take the perpendicular components of all these things, because this B, V, and L all are perpendicular to each other basically. So now the magnetic field over here is how much? So, or either we can do, what we can do is we have to find the V cross B and multiply it with L. Okay. So when we do V cross B, so which velocities will be multiplied? V cross B, if we do it, see. So either we have to find the matrix method, find through the matrix method that V cross B, or we can do it like directly कि कुछ tricks है, but it is better to do it with your matrix method. So the formula will be EMF induced will be L into V cross B. All right, this will be the general formula. All right, so now let's do it. So if we do V cross B, I'll form the matrix. It will be I cap, J cap, and K cap, and it will become 4, 6, 8, and B is 2, 4, and 0. All right. Now I cap into, if I do it 6 into 0 minus 4 into 8 minus J cap into 4 into 0 minus 2 into 8 plus K cap into 4 into 4, 16 minus 2 into 6, 12. Okay. So this will come out to be minus 32 I cap plus 16 J cap plus 4 K cap. So this is my V cross P. All right. Now, if you find the magnitude of this entire thing, so this magnitude will come out to be 36. Okay. So the magnitude comes out to be 36. Now, this is what the per unit length thing. Okay. Wire is placed normal to the magnetic field, its magnetic velocity. So this thing will become okay. The next question. A coil of area 40 centimeter square and 100 turns is rotating about a diametrical axis at 1000 revolutions per minute. The axis is perpendicular to a uniform magnetic field 0.5. The value of the induced EMF developed is. So maximum value we have to find out. So whenever things are rotating, we use phi is equal to BA cos theta. And if we find the EMF induced, it is minus of d phi by dt. So it becomes BA omega, a sine of omega t. The theta is equal to omega t. So if we need to find the maximum value is BA omega. This is the Emax. Whenever anything is rotating. So Emax will become BA omega, and we just have to put the value. So 0.5 into area, number of turns 100, area of the coil 40 into 10 to the power minus 4, and 1000 revolutions per minute. Okay, so we have to find the omega over here in radians per second, because we are doing everything in like SI units. So 1000 revolutions per second will be equal to 1000 into pi by 30 radians per second. So we just put the value over here. So 1000 into pi upon 30. All right. So let's solve it. So it will become, these zeros will all get cancelled. This will be 20 by 3 pi volt. All right, so this will be my answer. So this is what you have to do. You have to remember that whenever something is rotating, E max will be equal to BA omega. Next question. The self-inductance of a coil is 15 Henry. If a current 1 ampere changes to 2 ampere within 5 seconds, the average induced EMF of the coil is. So how much is the E average? So general formula for E average is phi final minus phi initial upon delta T. In this case, when the inductance is given, we know that E is equal to L into di by dt. We can write it as E in L into delta I upon delta T. So depending on the situation, you have to use any of these two formulas. So L over here is 15. How much the current changes by 1 ampere in 5 seconds. So it will be 3 volt. So again, a simple question, you just have to figure out the formula kaun sa lagana hai. The mutual inductance between two coils is 2.25 Henry. If the rate of change of current in one coil is 50 ampere per second, the induced EMF in the coil is. So for mutual inductance, we can write E is equal to M di by dt. You can use this formula. So mutual inductance is 2.25 into 40. All right. So this thing will become 90 volts. Okay. Next question. Two coils of self-inductance 8 Henry and 4 Henry are wound on an insulating core. The coefficient of mutual inductance between them may be. So देखो M जो होता है उसका वैल्यू होता है K under root of L1 L2, where K is the coefficient of coupling. Right? And K is less than 1. So basically M is less than equal to under root of L1 L2. So if we find it out, it will become M will be less than equal to under root of 32. Now under root of 32 means the value can be 5. Okay, it can't be 6. Only it can have 5 value. Okay, so 5 will be the answer. If it was 36, 5 and 6 both can be the answer. Okay. Next question. A wire of total length 2L is bent at its midpoint so that the angle between the two halves is 90 degree. So this is L and this is also L. Okay. So this thing will become root 2 times of L. So what is the induced EMF? When we find the induced EMF, we always take the length of the straight line joining the end points of the wire. So this is what we need. Okay, velocity is perpendicular, magnetic field is perpendicular. All three are perpendicular. So E will become B. B is how much? The value is not given. Root 2L into V. All right. And how do we find it out? So we have to use like the Fleming's right hand rule, okay, for the induced EMF direction. So magnetic field is like this, current, magnetic field is like this, current is like this. So the higher potential will be at point P. Okay, so higher potential will be at point P and lower potential will be at point Q. So it will act like a battery like this, and its EMF will be B into root 2 into L into V. All right. Next question. A metallic ring is fixed horizontally to a wall. A bar magnet is passed vertically downward through the ring. What is the direction of induced current in the ring as viewed from the above? So, if the south pole is approaching, it will behave like a south pole initially. So, if it is behaving like a south pole, the current is clockwise. When this thing passes through it and the north pole will be receding, all right, the north pole will be receding from it. So what will happen, this face, the lower face, will try to attract it. So the lower face will behave like a south pole, so the upper face will behave like north pole. So then the current turns anti-clockwise. So first it will be clockwise, then anti-clockwise. All right, first, when we have to see from this face only, this face will decide. So when I'm telling you again, when the south pole is approaching, this face behaves like a south pole because it wants to repel it. When it passes through it, the north pole, when you see from the lower face, the face below it, the north pole is going away from it, so it will try to attract it, so it will behave like a south pole. South pole, it is behaving like a south pole, so this upper face will behave like a north pole. All right, next question. The equivalent inductance of two inductors is 4.8 millihenry when connected in parallel and 20 millihenry when connected in series. Okay, so let's say the two inductance are L1 and L2. So L1 plus L2 will be equal to 20 millihenry, and L1 L2 upon L1 plus L2 will be equal to 4.8 millihenry. Okay, so from here we put the value of like L1 plus L2, it is 20. So L1 L2 will become how much? 96 millihenry. All right, so now we have to find the values of the individual inductances. So what we can do, either form a quadratic equation or do by hit and trial. Okay, so this is not the answer because 15 into 5 is like 75. This is not the answer. Okay, and this also won't be the answer because L1 into L2 has to be 96. So this is the only option that we have. So rather than forming the quadratic, you can do it with putting the options. Okay. Next question. Yeah, the graph questions, they are very important. So the current in the coil varies with time as shown in the figure. Which graph represents the EMF induced? So you can say that E is equal to minus of L di upon dt. Okay, whatever is the inductance of the coil. So, and di by dt will be the slope of this coil. So E is equal to negative of slope. So how the graph will be, just draw it over here and we'll match it up with the options. So this is my induced EMF. Now the slope here is positive. Its slope is constant. All right. Slope is positive, so EMF induced will be negative. Slope here is 0, so it will become 0 over here. Now the slope here is negative, so the EMF induced will be positive and it will be a constant like this. So graph will be like this. Now which graph is matching? This graph is matching. So this will be our answer. In the circuit shown, what will be the voltmeter reading? Okay, so here the VL and VC are both 300 and 300. The circuit is in resonance. That you have to identify. So V net will be equal to VR. So V net is how much? 220 volts. So VR, the reading will be 220 volts. And about the current will be V by R. So 220 upon, it will be 100. So it will be 2.2 amperes. Okay. Next question. A transformer has NP is equal to 30, NS is equal to 2500. If the input voltage is V is equal to 200 sine omega t, the RMS voltage across the secondary coil is. So we know that ES upon EP is equal to NS upon NP. So ES will be equal to NS upon NP into EP. So we have to find the RMS voltage. All right. So if we want to find this secondary voltage into RMS value, we have to put the primary as well in the RMS only. So this is V naught. So V RMS will be equal to V naught upon root 2. So it will be 200 upon root 2. All right. So ES will be 2500 upon 30 into 200 upon root. Okay. And if we solve it, we'll get this value. Okay. Just solve it. It's an easy question. You just have to remember that when RMS is asked, you have to give the answer in RMS. Okay. So whatever the input you give, the output you get. So you put here RMS, you get the answer in RMS. All right. In a AC LCR circuit, R is 100 ohm. When capacitance C is removed, the current lags behind the voltage by pi by 3. Okay, so let's do it step by step. So we have an LCR circuit, C, and this is R. And R is 100. Now they are telling us the capacitor is removed. So it becomes an LR circuit. So let's draw the phasor for LR circuit. So the phasor will be like this. This will be the current. VR will be like this. And VL will be here. And V net will be over here. So the current leads the voltage. When C is removed, the current lags the voltage by pi by 3. So this angle is pi by 3. Okay. Okay. So now let's write the equations for it. So tan phi will become VL upon VR, and it will be tan be root 3. Okay. This is my first equation. We have to find the impedance of the circuit. So VL will become root 3 times of VR. Similarly, draw the phasor for the second condition. When L is removed, the current leads the voltage by pi by 3. So when L is removed, the phasor will look like this. This will be VR, and here it will be VC. And this will be V net, and this angle is again pi by 3. So from here we can write that tan pi by 3 is equal to VC upon VR. Again, it will be root 3. So VC is equal to root 3 times of VR. So VL and VC are equal. VL and VC are equal, so the circuit is at resonance. So the impedance will be equal to what? VR only. Z will be equal to, Z will be equal to R, and it will be 100. So थोड़ा सा इसमें ट्विस्ट करने का कोशिश किया गया, बट यू हैव टू रिमेंबर कि LR सर्किट के लिए फेजर क्या होगा, RC सर्किट के लिए क्या होगा, एंड व्हेन VL and VR comes out to be equal, the circuit is at resonance. Okay, so it's a good question. Just remember it. Next question. A bulb and a capacitor are connected in series in an AC mains. Some activity is done and the bulb glows brighter. The activity must be. So basically it's an RC circuit, right? Now you have to, and this on place of this resistance, there is a bulb. So if the bulb has to grow bright, the current should increase. The current should increase. And if the current increases, the Z should decrease. All right. So let's write the value of Z. So it will be XC square plus R square. Now XC is what? 1 upon omega C. So I can write it as 1 upon omega C whole square plus R square. Now Z you have to decrease. So if you have to decrease Z, you have to, if you increase this, okay, increase the omega, all right, this entire fraction will decrease, so Z will also decrease. Okay, so frequency of the source was increased. This is the incorrect option because it is saying that the decrease. Location interchange करने से कुछ नहीं होगा, so it is also wrong. The plates of the capacitor are pulled apart using the insulating. So capacitance is basically A epsilon naught upon D. when you increase the D, the capacitance will decrease. So if this thing decreases, ये बढ़ जाएगा. All right. So this is also incorrect. It might be correct if it is said that the plates are brought together. तो वो भी option हो सकता था वहाँ पर. ठीक है. So this is how you have to do it. It's a good question. In the circuit, the current lags EMF by 53. So phi is equal to 53. So how much will be the power factor? Cos phi is the power factor. So cos 53 is equal to how much? 4 by 5. So it will be 0.8. Okay. Again, an LCR circuit, the readings of the voltmeter and ammeter of an LCR circuit, it's a favorite of NEET. It's very important. Solve as many as LCR circuits you can. Okay. So here the XL is equal to XC. The circuit is at resonance. When the circuit is at resonance, what will happen? The Z will be equal to R, it is 10. So current will be 40 upon 10 and it will be 4 amperes. Okay. And what you have to find out? Volt. So V equal to I into R. So it will be 40 volt. All right. If a transformer, the input voltage and the input current, so this is VP and this is IP respectively. If the output voltage, so it will be VS, and the output current IS are this, then the efficiency. So efficiency of transformer is what? P out upon P in into 100. All right. So efficiency will become P out will be how much? 450 into 220, and P in will be 10 into 11 kilowatt. So 11 into 10 to the power 3. So this gets cancelled. This will be 2. This will become 900 upon 1000 into 100. So this 100 cancelled, 90% will. So just you have to do the calculation and apply the simple formula. So transformer basically has two types of questions. One can be asked on the efficiency of the transformer. Another can be asked on like the input voltage, output voltage, or number of turns, whatever. The current passing through a hot wire ammeter is made up of two components, a DC component and an AC component. So find the reading of the ammeter. So reading of the ammeter will be basically the RMS value. So what will be the current? The current is 3 plus 4 root 2 sine of omega t. Okay. Now what you have to do? RMS value, so you have to first square. All right. So square. So 3 plus 4 root 2 sine of omega t whole square. Then you have to take the average. So take the average and take under root. This will be the IRMS. I'll give you a direct approach for this. So IRMS over here will become, let's expand it. So it will become 9 plus, this will be how much? 16 into 2, 32 sine square omega t plus it will become 24 root 2 sine of omega t. Now take the average of all these and take the under root. So average of 9 will be 9 plus. Now the average over here, it will be 32 upon 2. Okay, the sine square का average 1 by 2 होता है. So it will be 32 into 1 by 2 plus साइन का एवरेज 0 होता है. तो साइन स्क्वायर का एवरेज 1 by 2 होता है, कॉस स्क्वायर का एवरेज 1 by 2 होता है, साइन एंड कॉस केवल है, उनका एवरेज 0 होता है. तो दिस विल कम आउट टू बी अंडर रूट ऑफ 25. So it will be 5 ampere. So a direct approach I can give you that if it is given that I is equal to I naught, so maybe I1 plus I2 sine of omega t, and IRMS can be directly written as I1 square plus I2 square upon 2. Whenever sine is multiplied, just divide by 2. If something is given like this, that I is equal to I1 sine omega t plus I2 cos of omega t. Something is given like that, and you have to find the IRMS. Then IRMS will become under root of I1 square by 2 plus I2 square upon 2. So this is what you have to remember. Okay. So both PFO, and it's very important. Can be asked in the exam this year. So I have come up with different variety of the LCR circuits, all possible equations that can be given on the LCR. So here again, it's an LCR circuit. The frequency with which the circuit drives, so the resonant frequency is how much? 1 by under root of L into C. So everything is given. So it will be 1 upon under root of L is 5 into 80 into 10 to the power minus 6. So the frequency will become this thing, uh, it will be 10 ki power minus 3. So it will go upper, and this will be under root of 400. So it is 20. Okay. So this becomes 50 hertz. Okay. So this is what you have to remember. कि formulas पता होना चाहिए, formula steps पे होने चाहिए, resonant frequency का formula. Then given data से निकाल लिया. All right. So these were the questions there which are very likely to be asked in the exam from these two particular chapters. Again, these two chapters are easy because there are not a lot of formulas in the chapters. जैसे EMI में भी basically एक ही formula is equal to minus of d phi by dt, and we use it in different forms. Similarly in AC circuits as well, अगर आप LCR circuit आपको आता है अच्छे से, if you know the LCR circuit, you automatically know all the other things. Just a few things are remaining कि average value क्या होगा, RMS value क्या होगा, and transformers. So the formulas are not very much complicated. बहुत ज़्यादा multiple भी नहीं है. If you remember the general things, so you can derive or maybe remember the other formulas as well. So just practice the questions. Only thing that is needed in AC and EMIs is a little practice. So the questions that I given you, please try to solve them again and again. Solve them 2 times. So you will remember कि हर question में क्या approach होना चाहिए. And definitely आप देखिएगा कि your NEET exam on 21, you see some similar questions from these questions. So keep solving the questions, keep practicing, keep solving the previous year's papers. Okay, and we are bringing you some good questions over here. In the last chapters also, try to solve them as well if you have missed any of them. And just don't do it one time. Try to do at least thrice before the exam, so you remember the approach of each and every question. We'll meet in the next session with some different chapters and new questions. So till then, practice them, read the chapters, solve the standard questions. Thank you very much.